today we will begin this the topic mechanical soil erosion control. We have discussed about soil erosion. Essentially we have discussed about how soil generally becomes eroded, and the typical mechanism of soil erosion has already been explained, and we have also explained that how this landslides usually take place. So generally the part of the typical physical mechanism that takes place in such situations we have already discussed. We would now today discuss about how this can be controlled, the soil erosion can be controlled. I explain one important thing about erosion is mostly about the rainfall, is about the rainfall being very important. So this is in areas of high rainfall, obviously in areas of high rainfall, obviously the barren slope having soil cover will undergo higher erosion, than that of in a high rainfall, low rainfall area. Okay. So with these things, so you can high rainfall area, mostly in high rainfall area, we need to build mechanical soil erosion control structures. We need to build mechanical soil erosion control structures, particularly in high rainfall area, with the purpose, with the following objectives. Reduction of runoff, obviously, then arresting fines like silt and clay, arresting the drainage of fines like silt and clay, reduction of runoff that I have already said, stabilization of slope, and also the finally to retain the vegetative potential of the soil, to retain the vegetative potential of the soil, right. So this is, as you can see, these are the objectives of say mechanical soil erosion control. Now we will begin the discussion about how the soil erosion control, the structures that we generally do. So the mechanical soil erosion control, let us discuss about say this the one very important thing is the terraces. There is mechanical soil control measures, and the first one, the mechanical soil erosion control measures, the first one that the structure, the terraces, TERRACES, terraces. These are the structures. Terraces are the structures that we we would require to construct. Say particularly in a relatively flat slope, like this. Here, if this is the slope area, this is the slope. The construction of the terrace is like this. See, this is what the area that would be excavated. That is the area that would be excavated. This is the area excavated, and this area, this would be dumped here or stabilized here, like this. Stabilized here, like this. So here, this area, as you can see, this area would be excavated. This area would be excavated and would be dumped here. So here, this would be the dumped area, and as a result of which you can see now, that we have made a terrace. We have made a terrace which looks like this. We have made a terrace which would look like this. So what is happening here is, say, the most important thing about all these areas is that the rainwater, instead of being running through the slope, instead of being able to running through the slope, would finally accumulate here. So this, as a result of that, the velocity of the runoff will decrease. And this as it would be decreased, so the erosion over the complete surface would be reduced. So similarly, here what is important here is, so as this, what we are trying to resist is that the objective is to resist the flow of speeding water across the slope, and by doing that to make water to settle at the bottom of the terrace. The terrace will have a positive gradient, so that water can accumulate below. Sometime it is important. Sometime in cases of like this, in cases of these terraces, in terraces like this, as the terrace now here looks like this, as the terrace looks like this, as now the terrace nearly looks like this, there may be a requirement of some hard facing of the terrace. Say hard facing of the terrace, instead of fine particles being here, we would try to put in some boulders and compact this area so that the impact of velocity on the terrace becomes less, and that can substantially reduce erosion, substantially can reduce hard facing by means of boulders. So this gives you this is one kind of terrace. This is called when the slope is gentle. See, the slope is about, say here, if you can see this slope is being about, say, 15 degree to 20 degree. We generally call these terraces as broad base terrace. The gentle slope terraces are known as broad base terrace. So here, how do they look? This is just a cross section. If you just take a front view, of a terrace, here it would be quite looking like this. Say, in case of a slope like this, you just see you're facing this slope. Say here, you see this is where this the green one shows the water line of the terrace. These are called the water lines. Water lines of the terrace. You see in the last picture that we have shown, the water line of the terrace is here. This is where the water line of the terrace. So, through which the water would begin to pass. So, as you can see, this would be in encircling, as you say, in a mountain road or in a road near a slope. As you can see, as the slopes keep rounding off. So, similarly, all these slopes would be combining together, and the water which is supposed to come out through the slope would be diverted to the terraces, and through the terraces it would come down at the bottom. Okay. This is a particular kind of terrace. This is a broad based terrace that I have discussed. So there are a few other kind of terraces, like, say, this kind of terraces are also common, where you can see this is a terrace also. This is what you can see here is we have what we have made of a gentle, very gentle plane slope from a very gentle slope, a steep back slope, slope terrace, has been formed. So you can see there back slope terrace. So it's a constructed ridge. This is called a ridge. This is what to say. This is what the material would be mostly. Say this is called steep. This is steep slope. This is the back slope. So this together, steep back slope terrace, that is what the name is generally derived. So the ridge is constructed. So here it just tries to show here that the initial from the initial level, as can be seen here, from the initial level, drawn in black, you can see this is how the ridge has been formed. So the ridge has been formed, and this we have found out is steep back slope terrace has been formed. There are a few more types of terraces, we'll just also see them. This is a steep back slope terrace that is generally made out of there's a flat channel terrace. This is a flat channel terrace. This is a flat channel terrace. You can see this. From this we have made the fine sediments get collected over here, and the water essentially remain on top of this water. This is the red one showing the water level, whereas this one showing the fine eroded material, and this is called a flat channel terrace. Flat channel terrace. There are another type of terrace, which is quite common as well, which is known as, say, made out of, say, if there is in a slope like this, depending on the rainfall, as well as to see what we have made out of a gentle slope. See, this is the original ground line. original ground line, across the slope increases, availability of water across the slope increases. Another very important thing today, this is another is for water recharge to groundwater. Water recharge to groundwater. So, these are as you know, mostly most cases, something like water recharge to, and the third one, if you just point it out, almost similar, though you might sometime hear this term. This is known as water harvesting. Availability of water across the slope increases. So, across the slope increases means the water that was generally flowing down the slope is being arrested at different places. So, suppose that say the slope of say 400 feet or say 500 feet. In such cases at say 300 feet also you have a source of water, because through the diversion ditches that the water you are collecting, you can collect in a pond, or you can collect in a well, or you can collect in any other tanker, things like that. So, the water availability across the slope increases, water recharge to groundwater improves, because it's a very important nowadays that the groundwater regimes are recharged. India is facing serious groundwater problem because of the low recharges. The recharges is most of the groundwater sources are being pumped out daily in and out, but they are not being recharged, completely recharged by rainwater. Unless that is done, the stock reduces. This kind of techniques, this kind of methods can help improve the water recharge to groundwater, and also water harvesting. Water harvesting, say particularly important is that the water that is available in the rainy season, if we can store them, at appropriate places, that water can be useful during the other times when there is no rain. So, these things, water harvesting is becoming extremely popular nowadays in India, across small streams, small ponds, this water harvesting is being applied, and in many situations it has given dramatic results. Particularly in many villages, it has helped improve the life of the villagers by leaps and bounds. I mean, in many cases, because of water harvesting, a village may be able to generate 2 or 3 crops in a year, in comparison to 1 crop that it used to do in a year. So, as a result of that, number of economic benefits have also accrued, and not only that, it has also served the use by means of drinking water. Say the drinking water is also being more available with the effect of such kind of structures. So, here we see that these are the terraces, that the flat channel terraces that we make, say bench terraces. These are the different types of terraces and their uses. Okay. I mean, there are some design aspects. The design aspects are very simple. I mean, it's not much of a thing here is to say, is observe is that depending, as I have said, so depending on the structure of the slope, depending on the availability of the slope, you can, and the rainfall pattern, you can try to think of how you are going to, what kind of terraces you are going to have. You should also have an understanding how much rainfall you expect, what should be the catchment area by which the water can be actually caught into, so that the water should not spill. I mean, your design should be such that the water does not spill out from the terraces. So, these are some of the things that the design aspects that are generally simple in nature, but are also very useful. Okay. Now, having to say this, with these things in mind, the next is the diversion ditches. After what is is mostly in cases of diversion ditches, the examples of this generally either independent or connected with the terrace. The diversion ditches are constructed. Diversion ditches are constructed to serve independently, are constructed to serve independently or in tandem with a terrace, with one or more terraces. The usual structure is not much of a difference. Here, if you have already seen, you say a typical broad base terrace. The diversion ditches are like this. Okay. And if we see this, the diversion ditches like this, we have in places of say, we also keep a diversion ditch, so that this is known as the diversion ditch. As against, as I have said, there may be only diversion ditches also. Here, in such cases, say in a slope generally, you have diversion ditches like this. All right. So these are the diversion ditches. These are the diversion ditches which are generally used in tandem with the terrace. This is the terrace and diversion ditch. And this one is only diversion ditches. So this is also another method of arresting water to flow. So you can make an intermittent passages inside the slope, so that the water can be carried away. The water can be carried away. So this is the construction is depending on the rainfall. Depending on the rainfall and soil characteristic, the ditch is constructed the following shapes. Like this, depending on the rainfall and soil characteristics and the demand, that is about the soil, about the demand of the ditch, they are constructed with the following shapes. The following shapes are like this. The shapes are generally a wide ditch would be able to, in case of the soil being, if in case of, there is lot of fine soil existent in the soil, in the slope itself. So here we would generally try to reduce the velocity of the water. So this the water that is the water that is coming out, say water that is coming out through this water which is coming from the surface, from the slopes, these slopes, this water would be, the velocity should be reduced. So the velocity should be reduced means we will be finding finer particles to settle, here. This is where the finer will be settling here. If we are trying to say put all the fine particles to a particular storage at the bottom, I'll talk about, say, something like this. If it is so here what we are interested is the sediment to be carried away, So as a result of that, you would expect, say, here there would be a relatively higher velocity at the bottom, and so this would not allow this shape, will not allow the fine particles to settle, at the bottom, because of relatively higher speed. This shape will not allow the fine particles to settle at the bottom because of relatively higher speed. So the fine particles would not be collected on the terrace or on the diversion ditches, right? On the diversion, they would be generally carried away. So there are different types of shapes. There are other types of shapes, like, where it might also have a shape like this. And then, this kind of shapes are also common, where this is one sided be more than the other, or say this one. So different types of shapes that we can generally find, say different shapes for diversion ditches, different shapes for diversion ditches, right? Apart from that, in another very typical, typically important, as mechanical soil erosion control method is, say, sediment pond. The sediment pond. The construction of the sediment pond is the sediment ponds are constructed to arrest the fines displaced during the rainy season. Sediment ponds are constructed to arrest the fines displaced during the rainy season. To be again spread back to the slope surface to the slope surface. Sediment ponds are constructed to arrest the fines displaced during the rainy season to be again spread back to the slope surface. To be again spread back to the slope surface. To be again spread back to the slope surface. Okay. Now this is what we'll just see how these sediment ponds are constructed. How these sediment ponds are constructed. The typical sediment pond is like this, which is just like the sediment ponds are, you see, across the slope. If you just see, this is generally say across this slope, sparsely vegetated soil slopes like this. You'll find here that this one is okay. You see, you are going to see only one face of the slope. Just this is one face of the slope. You see, the slope would be, you are not being, you see, this is mostly the slope like this, the slope spreading up, this spreading up. And okay, just for that case, just consider that the slope, the sediment ponds is like this. Here the sediment pond is constructed like this. This is what okay. Okay, so this the water across, water coming from this, coming from across the slope, gets collected here, and this is what is a sediment pond, where you have a flood level. This is earthen or made retaining wall, brickwork make retaining wall, and as you can see here, as you can see, this is how it would look like. So, if it can be seen like this. All right. So here you see this. Say this one is typical. Say sediment like this. So here this one is the soil surface. The brickwork, this is collected water, and certainly as you can see the collected water, there would be one HFL, highest flood level, after which you would allow the water to pass through the sediment pond. So here the sediment that is collected, which is of considerable, in amount, this sediment would be again during rainy season, during winter season, the sediment would be again spread back on the slope. Spread back on the slope. So sediment ponds, this is sediment ponds are of a great use nowadays. These sediment ponds are finding wide application, and this we can see that this particularly in situation like this you just write down in a few lines on this. The sediment ponds are mandatory for slopes having high erodibility, mandatory for slopes having high erodibility and to keep the soil fines important for the texture and structure of the soil, texture and structure of the soil. So, the sediment ponds are quite in use, important for the texture and structure of the soil. The sediment ponds are in great use. Sediment ponds are nowadays almost always used in various constructions, like very popular or much applicable in dams, embankments, mine slopes, and then say and other construction projects. This much applicable. The sediment ponds are quite in great use actually, and great use in areas like dams, embankments, mine slopes, other construction activities like road making, etc. The sediment ponds serve a great purpose. All these serve a great purpose, help in greatly reducing the erodibility of soil, and thereby reduces the impact of rainfall, essentially rainfall on the slope, to reduce the erosion, as to arrest the fine particles. This remains, these are very important structures. They are greatly used. I mean, it's not to say, in almost all cases, as you go towards, in a construction site or go towards a travel by a roadside, if you just observe, the similar kind of structures are very much in great use. Mostly the sediment pond and catchment ponds, all these kind of things you would very well see, mostly in the mountainous roadsides, and greatly improve the soil slope, helps in keeping the slope dry, helps in keeping the helps in reducing the failure of slopes. Various other benefits can be obtained with the construction of this kind of structures, mostly in the slopes. Okay, we'll come back to the next class after a 5 minutes break, right? Okay. Okay, before we actually go into this detail of this soil erosion prediction, we need to discuss something more about this mechanical soil erosion control and a continuation of that. This is we call this as in the next one is apart from this mechanical soil erosion control, we also use another control for to stop and check erosion, like this. This is called is vegetative control. Vegetative control. The vegetative controls are like this. I mean, you say, if you are just trying to observe a particularly a slope, particularly a barren slope, how it looks like. So, here, say here, if it is a slope like this, say here, the slope, is broken at places like this. The slopes that we generally observe here, what is this slope when it is completely denuded, completely barren. So, this is barren slope. Barren slope means you don't have any large plants, you have small plants, shrubs like structures, not even that. Mostly this barren slope you will find near this freshly exposed slopes, new dumped slopes, where there is practically no vegetative cover. In such cases, what we generally try to do is, we have also found talked about this earlier. What we do is, generally we try to spread some vegetative material on the surface of the slope, What are these vegetative materials? These vegetative materials, depending on the availability and the requirement, we generally spread vegetative material spreading of vegetative what are these vegetative materials? Mostly cut haze, fallen leaves, say wood cuttings, are generally spread all over the barren surface of the slope, So, these they work the material works as the buffer for the rain, buffer for the heavy rain, thereby substantially reducing the impact on the slope, though much depend on the quantity, of the vegetative material, they can the the effort can reduce the soil erosion by about 50% over a year, by about 50% by about over a year. So, much depends on the vegetative material works as the buffer for the heavy rain, thereby substantially reducing the impact of the slope. Though much depend on the quantity of the vegetative material, the effort can reduce the soil erosion by about 50% over a year. So, this is also another very standard technique. This is also a very standard technique of is just in case just to suggest you another important thing is that when you are we generally cut grasses in our gardens or any other places or collect leaves, they can be a very important resource. This can be very important resource, particularly in areas where there are very little vegetative growth. This vegetative growth and very little rainfall, this kind of material, if it is spread over a large surface area, they can substantially improve the quality of the soil over time, and not only that, can reduce erosion to a substantial amount over the years. So, having to say all this thing, now we can see that this is how the erosion can be checked and controlled, and at the same time there is a necessity for, in most cases, for how much there should